Hundreds of millions of years ago, huge dinosaurs lived on Earth. Their growth, weight, size were almost gigantic. Tens of millions of years ago, they were replaced by no less gigantic mammals. And then everything abruptly ended. What about everything in order? The gigantic sizes of prehistoric creatures boggle the imagination. Dinosaurs reached body lengths of more than 30 meters. That's the height of a 10-story building. And the weight, according to various estimates, could reach 80 or even 120 tons. The mammals that replaced the dinosaurs were smaller, but also reached considerable sizes. For example, giant sloths 6 meters tall. Or Indricotherium, a rhinoceros ancestor reaching 5 meters at the shoulder and weighing 17 tons. Mammoths are well known by all. However, you won't encounter such animals now. Why? The most common explanation from scientists is this. Well, that's how it turned out. It's hard for a huge animal like a yak to survive. It's so hard that dinosaurs lived for 25 million years. There are other answers, but they all somehow come down to something like this. But giant animals exist somewhere to this day. Ocean. It is there in much denser conditions that giants still live to this day. Those same blue whales still reach sizes of more than 30 meters and weights of more than 150 tons. However, the obvious conclusion that the Earth's atmosphere was much denser in the past than it is now is carefully avoided by scientists. So what could the density of the atmosphere on Earth have been? Purely empirically, based only on the sizes of prehistoric creatures, the conclusion is drawn about a density close to the density of water. However, just hint at this, and official science will start to diverge in streams of indignation and wrath. Calculations show that at pressures of 7 to 8 atmospheres, some substances familiar to us begin to exhibit unusual properties. Chlorine, for example, ceases to be a gas and becomes a liquid. Also, as pressure increases, so does temperature. But it's not all that simple. We always have the eternal example of water before us. In the ocean at a depth of 4 kilometers, the pressure is more than 400 atmospheres, yet the temperature remains around 3 to 4 degrees. Secondly, when we talk about a denser atmosphere, all slightly scientific people start saying that it will melt us. This is both true and not true at the same time. Fish in the ocean, whales, sharks, dolphins are not crushed. So what's the matter? The matter is in the difference of pressure outside and inside the body. The internal pressure of sea dwellers is practically the same as outside. The same can be said about terrestrial inhabitants. In other words, if you are underwater in a diving suit, you will explode sooner or later. If you breathe water, then no. This is not just a fact. Scientists have long been trying to come up with a way to breathe specially prepared liquid into the lungs based on perfluorocarbon compounds and carbon dioxide dissolved in water. And it must be said, unsuccessfully. Not long ago, an experiment was shown that was conducted on dogs, which were able to breathe water. Such a method of breathing allows to equalize the internal and external pressure and to dive to practically unlimited depths. In other words, the high density of the atmosphere will not affect you and will not crush and will not tear apart in case you breathe it, and the pressure in your circulatory system is the same as outside. Of course, additional measures may be needed, but the body is quite a universal thing after all. It can adapt to a different percentage ratio of gases, and even to different gases altogether. Divers, for example, often replace atmospheric nitrogen with helium during deep dives, and they reduce the percentage of oxygen to a minimum. A person can withstand a pressure of up to 15 atmospheres relatively calmly, but records have been set at 40 atmospheres and even more. But scientists continue to manipulate consciousness and information. Try now to figure out what the maximum density of the atmosphere is possible on Earth. They will overwhelm you with calculations, numbers, formulas, confused explanations, imperceptibly replace the concept of pressure and density, and in the end you will find out that a denser atmosphere cannot exist on Earth at all. A maximum of +5 to +7 atmospheres, and at most 2. And then it's a dead end. It's impossible for countless reasons. And it seems like nobody is hiding anything. But when you ask a scientist a direct question, he just won't understand you. Cognitive dissonance occurs, and he starts answering a completely different question. So what to do? Let's look into the near space. Not far from us, at a distance of only 50 million kilometers, a precise copy of Earth-Venus is orbiting around the Sun. The difference in size between Earth and Venus is only 35 kilometers in radius. Venus is slightly smaller, but that's hardly anything for the difference to be strongly felt. On Venus, the force of gravity is almost the same as on Earth. It's twice as close as Mars. However, it has an incredibly dense atmosphere. It's practically 93 times the Earth's atmosphere at the surface. That is the fact that Earth's atmosphere could have been, but was almost inevitably denser than it is now. And yet it's only twice as thick as Earth's, about 200 kilometers. And that's why we've practically forgotten about it over the last 60 years. And it's done so subtly and skillfully that any more or less educated person will immediately tell you 1,000 reasons why it's impossible to colonize Venus. Although until the end of the 80s it was studied very aggressively, and then, with the collapse of the Union of Soviet Socialist Republics, interest suddenly sharply declined. Suddenly there came a realization that it was impossible to colonize Venus, and all eyes turned to Mars. And no one even thinks that there might be some kind of deception hidden here. Well then, I'll try to sow the seeds of doubt in your minds. So, what can an ordinary person know about Venus? Venus has an incredibly dense atmosphere, and thanks to it, there's a greenhouse effect, and the surface temperature exceeds 460 degrees. Venus is too close to the Sun, and therefore a normal atmosphere there is impossible. Venus rotates extremely slowly and in the opposite direction, which is why a day there lasts almost 2 Earth months. The atmosphere on Venus is not only dense, but also acidic. Now let's go through the points one by one. First, let's deal with the acid rain. Turns out, sulfur dioxide, which supposedly creates these rains, makes up only 0.16% of Venus's atmosphere. But that's not all. At temperatures above 450 degrees, sulfuric acid simply decomposes into water and sulfur. And since, according to official data, the temperature at the surface of Venus is above 460 degrees, acid rains never reach the surface. They are concentrated at altitudes more than 50 kilometers above the upper layer of the troposphere. Below, closer to the surface, carbon dioxide is concentrated, which makes up 96% of Venus's atmosphere. But it's not in the state there that we're familiar with. Thanks to the high pressure and high temperature, it transitions into a state of supercritical fluid. This is when a gas under high pressure acquires the properties of both a gas and a liquid at the same time. The density of such a substance makes up from 10 to 80% of the density of water. Under such high pressure, carbon dioxide is capable of retaining supercritical properties even at a temperature of plus 31 degrees. That is, it's almost a liquid in which you can freely swim, an ocean of viscous carbon dioxide. What does this tell us? So far about nothing. However, let's remember this nuance. There is one more unpleasant fact: the proximity of Venus to the Sun, which literally scorches the surface. But is this really the case? The distance from Earth to the Sun is 150 million kilometers. And on different parts of the Earth's surface, temperatures of both plus 50 and minus 50 are possible at the same time. Everything depends on the angle of incidence of the sun's rays and the reflection coefficient. At the equator, the rays fall at a right angle and heat the air. At the poles, the sun's rays slightly touch the surface and reflect back into space. Moreover, each of us has noticed that at night, and simply during the rain, or even when a cloud appears in the sky, the temperature drops. And this is felt quite sharply, and if the night lasts long, then the temperature drops to critical negative values. Has anyone conducted measurements of temperature and atmosphere at the poles of Venus or on the night side? To reach the pole, you need to occupy a polar orbit, which requires additional fuel and resources. What is hidden on the night side of Venus? On December 15, 1970, a Soviet apparatus, Venus 7, was launched into the planet's orbit. And immediately on the go, having made only 2 orbit corrections, it plunged into the planet's atmosphere. After which the apparatus successfully landed deep on the night side of Venus and began transmitting data. So how did it start? During the landing, his telemetry failed at the communicator, and for some time it was not clear where he had landed. And after landing, it began transmitting data about the temperature, which reached 475 degrees at the surface. These data were transmitted for only 20 minutes. After which the device fell silent forever. But everything seems clear. The temperature on the night side is also enormous. The device has confirmed it after all. However, let me remind you that the device entered Venus's atmosphere at a speed of 11 whole and 2/10 of a kilometer per second, cutting through the dense layers of the atmosphere and experiencing loads of 35 G. For comparison, the Columbia shuttle entered Earth's atmosphere, which is almost 100 times less dense than on Venus, at a very shallow angle and low speed, but the loads did not exceed 7-8 G, and yet the plasma heated to more than 2000 degrees from friction against the atmosphere tore the shuttle to pieces. Our satellite experienced loads 50 times higher upon entering the atmosphere. It's hard to even imagine what temperature it heated up to. And for 20 minutes after landing, it only transmitted temperature data. But can we trust them in this case? What kind of data was it transmitting? The temperature of the atmosphere or the temperature of the semi-liquid gas around it, heated by its own floating casing? The Americans' second attempt to land on the dark side was in 1978. They didn't waste any time, and on board the Pioneer Venus 2 spacecraft, they launched 4 probes at once. 2 of them were supposed to land on the dark side, and 2 on the daylight side. As they say, these devices confirm the data obtained from Venus 7, although both night probes and 1 daylight probe simply crashed upon impact with the surface. There were no more attempts to land on the dark side. So what if the devices transmitted incorrect research? One remind you that the only device that landed, the Soviet Venera 7, landed with a non-working communicator. Its location was calculated purely empirically based on various effects similar to the Doppler. Even on Earth, the temperature range jumps within 100 to 30 degrees, from -80 to +50, which means that the temperature on Venus can freely drop to +25 degrees at night. But the main thing is not this. The point is that, despite everything else, Venus rotates very slowly and in the opposite direction, thanks to which days on Venus last half a year, that is approximately 117 Earth days, while a year on Venus lasts approximately 225 days. And this means that all that fiery sulfuric horror that they describe to us lasts only about 2 Earth months, and then on the unlit side, a polar night sets in for the same 2 Earth months. Scientists talk about unceasing hurricane winds, reaching 100 meters per second and more. However, such winds start at the upper boundary of the troposphere, where the pressure drops to 1/10 of the Earth's atmosphere and the temperature drops to -30. That is, no matter how strong the wind blows there, it carries not heat but cold. The troposphere itself is extraordinarily dense and viscous. That's why there are no serious winds there. Moreover, considering the pressure of 93 atmospheres and the density, these winds can already be called currents. Moreover, the Venus 9 apparatus determined during the landing on the planet that the wind speed at the surface is less than 1 meter per second. And here it gets even more interesting. In theory, at the border of day and night, cold and warm currents of carbon dioxide should collide, creating continuous whirlwinds. And in connection with this completely incomprehensible statement of Dmitry Titov, an employee of the Max Planck Society's One Institute for Solar System Research, that one quote, practically all of its atmosphere is involved in one gigantic hurricane. It rotates around the planet at a speed reaching 120 to 140 meters per second at the upper boundary of the clouds. We still do not understand how this happens and what supports this powerful movement. To be precise, scientists have encountered a paradox that they themselves have plunged into. Firstly, stating that the surface temperature is always above 400 degrees, even at night. Then, seeing a live example of convection, that is, hurricanes where cold and warm currents merge, they do not understand how this happens. And how to explain this? But the oddities do not end there. The same Dmitry Titov further states that it is known that the main sulfur-containing gas on Venus is sulfur dioxide. But when we start modeling the chemistry of the atmosphere on a computer, it turns out that sulfur dioxide should be consumed by the surface over a geologically short period of time. This gas should disappear if there is no constant replenishment. It is usually attributed to volcanic activity. That makes sense. Sulfur dioxide, falling as rain when heated above 450 degrees, decomposes into ordinary water and sulfur. Well, it should decompose. Scientists explain the presence of sulfur in the atmosphere of Venus by volcanic activity. However, we can take Earth as an example here. Even in our thin atmosphere, volcanoes rarely eject columns more than 20 kilometers above the surface. And on Venus, for sulfur to reach the cloud layer, it needs to be thrown 70 kilometers, overcoming a pressure of 93 Earth atmospheres in the process. Sulfur itself, which is heavier than water, oxygen, and even more so hydrogen, cannot reach such a height on its own, even considering volcanic activity. So maybe there's no sulfur there at all. There is. A thick veil of sulfur dioxide clouds reflects 75% of the sun's heat, which is why Venus appears to us as a bright star. And because of this, we can't see its surface. Thus, we only have access to radiolocation images. And here's another oddity. Despite the frequent flights to Venus up until the late 1980s, you'll have a hard time finding a handful of real images of the planet from orbit. 90% of all the images are either radiolocation, computer graphics, or artist sketches. What kind of paradox is this? After the year 1984, the studies of Venus suddenly stopped. In the year 1990, the United States of America sent the Magellan satellite into a polar orbit of Venus with the aim of conducting radiolocation. However, starting from the year 1993, under the guise of the Magellan experiment, they launched into orbit, covering the upper layers of the atmosphere, and by September of 1994, they simply threw it on the surface. Then, for 11 years of silence broken only 3 times by the passing Galileo, Cassini, Huygens, and Messenger spacecraft for gravity assist maneuvers on their way to Jupiter, Saturn, and Mercury. Then in 2006, the European satellite Venus Express was finally launched into a stretched polar orbit of Venus, which burned up in 2014 in the dense layers of the atmosphere. 4 years later, Japan launched its own satellite, Akatsuki. However, it failed to enter orbit on the first attempt, and the next attempt to enter orbit was only made 5 years later. In 2015, the Akatsuki apparatus finally entered Venusian orbit. However, due to a malfunction in the electrical equipment, 2 out of 4 cameras had to be turned off. By the way, all the cameras installed on the device were either infrared or ultraviolet. There are no regular cameras. The same interesting paradox applies to the ground shots of Venus from the dropped devices. Over 23 years of studying Venus, from 1961 to 1984, 24 devices were sent to it, 19 of which were Soviet. Over the next 36 years, only 6 devices were near Venus, of which only 3 became direct satellites of the planet. However, there are still radiolocation images. Let's look at them and compare with the radiolocation images of Earth. Now guess where this shot is from? From Earth or Venus? Obviously it's a river, so it's from Earth. And you guessed wrong. This is a shot from Venus. Scientists, after some thought, surrounded it with a lava flow. Thus, Venus, on the one hand, clearly gives us to understand that the presence of a denser atmosphere on the planet similar to Earth is quite possible. On the other hand, we are faced with a rather gloomy image of this planet from the scientific world. Nothing is known about the atmosphere and temperature on the night side. It's unclear what fuels the upper layers of the gray atmosphere. It's unclear why the temperature on the day side of the surface is so high, given that 80% of the solar radiation is reflected back. High pressure and density also do not explain this phenomenon. In any case, the pressure at a depth of 6 to 8 kilometers in Earth's oceans is quite comparable to the atmospheric pressure on the surface of Venus. But the temperature there does not rise above 4 to 8 degrees. So who to believe? Your own logic? Or data from a probe heated to 3000 degrees and lost its coordination system Venus 7, as well as devices Pioneer Venus 2 that broke down when they fell? World Illustration Magazine, 1871st year, volume 6, page 190. As evidence that the distance of planets from the Sun does not affect their climate, Colonel Drayton recently pointed out in the Geological Society to Venus, which is much closer to the Sun than Earth, undergoing a period of severe colds at present. Irvin Bird, known for his observations of the Moon, asserts that upheavals occur on its surface. Question: what happened to the Moon at that moment? Or with the Earth? And why is some colonel commanding troops explaining to scientists the behavior of the climate on Earth, using Venus as an obvious example in such a tone as if the weather on Venus at that moment was known even to a child? And why does this news coincide with the great American fires, particularly the Chicago one? Are they, newcomers from Venus?